Okay, in this video we're going to look at electrophilic substitution reactions with benzene. So we'll have a general mechanism, but first, as we go through this, I'm just going to go through what is electrophilic substitution. So if we have a look at the name, electrophilic substitution. Let's see here, first of all we've got to find what is an electrophile. So we're going to be taking an electrophile first of all, and that is an electron pair acceptor. So we're going to see a pair of electrons, they're going to be accepted by our electrophile. So look out for that in our mechanisms. They generally, an electrophile represented with an atom with a positive charge. Positive, it's going to want to take on electrons. Now the next bit, substitution, it just means we're going to swap it with something. So our electrophile is going to go on and something's going to come off. And that's generally another electrophile. So we're going to have an electron pair acceptor, so look out for that. That's going to be our electrophile, and we're going to swap it around. So our general mechanism is going to look like this. We're going to have our benzene. I'll do a general formula first of all. And that's going to react with our electrophile. So that X plus, that's going to become C6H5X. So our electrophile is going to join onto the benzene, and notice that we're losing a hydrogen. That's what's being swapped off. It's going to become H plus. You can see that's now balanced. Our positive charges are carried. Kind of just moved from the X plus to the hydrogen that we've swapped it with. So the mechanism comes in a few steps. So we have our benzene first of all, and then we have our electrophile. And what's happening is, we talked earlier, we got in the last video, we saw that this benzene is delocalized structure. There are 6 electrons delocalized in here. Well, a pair of them are going to come out and form a bond with the X plus. And that's going to give us an intermediate. So we'll have our X joined to a carbon and our H joined. And that actually means that carbon is bonded 4 times. So that's nice and exactly kind of, in a way, what it wants to do. The other carbons, they're bonded 3 times, and they've left 4 electrons in our centre ring. So we've got 5 carbons but 4 electrons. Overall, it'll have a positive charge. And then we've got this one that's all bonded. So the electrons here, we've got a positive charge here. These electrons in this hydrogen bond would actually rather be with the electrons over here. It doesn't really like bonding with hydrogen. The electrons essentially rather go with the 4 electrons in here, so those electrons disappear out and go back into the ring, meaning this hydrogen breaks off without any electrons. Just put an arrow in there to show we're going to different stages, which leaves us with our final product. We have now our benzene structure back with our 6 electrons delocalized in the centre and our electrophile added on. And we have our H plus taken out. So if we see this in the general formula, we've got C6H6 here, C6H6 here, with an electrophile. There's our electrophile. That goes to this intermediate, where everything's joined on. But these electrons would rather be delocalized in the centre, so the hydrogen breaks off, and that leaves our electrophile added on, and our H plus left off. H plus has lost its electrons. The bond where the electrons were, they've gone into the delocalized ring now. we start looking this into practice, the first reaction I'm going to look at is the nitration of benzene. And in this reaction, we have our benzene again. It's going to react with nitric acid with a catalyst. Now some of you will be screaming out what that catalyst is, and that is sulfuric acid, and that's going to form C6H5NO2 plus some water. Now in this one, a H plus has been given off, and we'll show where that H plus goes in the end. It kind of rejoins with other things as we go on. So the first step in this, and this is a 3-step process, we'll do a reaction, then the mechanism, then another reaction, or equation at least, is we have no electrophile in here at the moment. So there's nothing for to be substituted with the hydrogen on the benzene. So we have to create our electrophile. And to do that, we take our nitric acid and we react it with sulfuric acid. And that forms our nitro group, which is now positive, and that's our electrophile that can accept a pair of electrons. It's also going to form this HSO4 minus ion, and we'll also check that we'll balance that out. We're going to get some water. So that's our first step, and we can see here that that's our water up here that's going to get produced. Step 2 is our mechanism, and this is going to follow on from the general one we saw earlier. But now our X, we know what it is. It's our NO2+. So the first step is for that electron pair to go to the NO2+. The electron pair comes from those delocalized electrons in the centre. Now, if you've got time, a good practice would be to stop the video now, take that general and see if you could draw what the intermediate was, or it's going to be. I'll carry on going, and we'll have here a broken ring, and it's broken where I'm going to put the nitro group. It doesn't matter when there's nothing else joining to this. It doesn't matter where I put the nitro group joining on. Just out of habit, I tend to put it there. So that's our intermediate stage. And now these electrons are going to go back into that delocalized ring, which is going to form our nitro group added on, and that's our nitration of benzene. And we're also going to get that H plus there. Now, if you get to this stage and you're not sure what to do for step 3, you could have a look at the equation at the top and see what you've got, what you've formed during this practical that's not in this equation. And the first thing we're going to see is we've got our water, we've now got our nitro group, so that's all fine. So it's not going to be anything to do with those. But our catalyst, we changed over here. It's HSO4 minus. Now it's not a catalyst then if it stays as HSO4 minus, so we have to get it back. And luckily, there's no H plus in this formula either produced, so that H plus has to go somewhere. If we react HSO4 minus with H plus, we get H2SO4, which is then our catalyst back. And that is step 1, step 2 and step 3 in the nitration of benzene. Next one we're going to do is our halogenation of benzene. And this is benzene plus a halogen goes to C6H5 H5Cl plus HCl. Now if you'd watched the previous video, you'd be shouting at this point, but wait, benzene doesn't react with halogens, specifically bromine, but it wouldn't react with chlorine. And you're right, so we need here a catalyst. And there are several catalysts we can use. We call these halogen carriers. We could use AlCl3, we're using chlorine, so we could use FeCl3, or we could just use Fe. Any one of those will do. I'm going to use AlCl3 in this one. And again, we're going to have a three-step mechanism. Firstly, we've got to make our our electrophile. To do this, we get our Cl2, react it with AlCl3, and that's going to go to Cl plus, our electrophile, plus AlCl4 minus. And now we've got our electrophile, we can do our mechanism. So again, if you're all set up and ready to go, stop the video now and see if you can predict what the mechanism would be. So we'll have our benzene. We've got a Cl plus. So that Cl plus can accept a lone pair of electrons. So it's going to take from the delocalized electrons in the center, a pair's going to join with it. And that's going to form, we're going to do it on this one this time, just to show it can move around. Our delocalized ring is going to break, it's going to become positive. We're going to get a bond now formed with a Cl and a bond with a H. And then these electrons in the hydrogen bond would rather be here. So they go into there, which gives us Cl plus H plus. And we've halogenated our benzene. Step 3 is then, just like in the previous one, in the nitration, we're going to get our benzene back. Our catalyst back. To do this, we're going to take our AlCl4 minus, we're going to add our H plus, and that's going to go to AlCl3, which gets our catalyst back, and we haven't got this other product yet, and that's going to form now. The chlorine on here and the hydrogen here are going to join together, and that's going to form our hydrochloric acid product, our catalyst back, and our other product. And that's the halogenation. And they are the mechanisms you need to learn.